Okay, we've reached the point in the course where we're going to take a look at NoSQL storage methods. These are methods that are used when relational databases don't meet our needs. There's an expression that the difference between a data analyst and a data scientist is that a data scientist knows how to work with unstructured data. And NoSQL is all about storing unstructured, or perhaps more appropriately labeled, semi-structured data. NoSQL is a generic label for just about any data store that's not a relational database management system. NoSQL is not itself a specific technology. It's a label for a group of technologies, and in particular, all it means is not a relational database. It's a term of exclusion. So we use NoSQL storage methods for semi-structured data, and we use it in cases where relational databases don't meet our needs. Relational databases focus on ACID compliance, in particular atomic transactions where each transaction is all or nothing. It either happens or it doesn't. It focuses on consistency so that the database is always in a consistent, legitimate state. It focuses on isolation, where transactions don't interfere with one another, and it focuses on durability, where once a transaction occurs, it persists. Those are traditional focus points for relational databases. Sometimes we're more interested in performance, though. So a NoSQL solution is going to focus on availability and performance goals rather than ACID transactions. So basic availability is our primary goal. We want every request made of the database to be guaranteed a response of some sort. We want the database to be in a soft state, by which we mean it'll typically eventually reach consistency, but it may change over time as it moves toward consistency. So at every given moment, it's not in a consistent state. For example, if you have $1,000 in your bank account and you give me $1,000, a traditional relational database is going to want that $1,000 only to be in one place or the other at any given moment. But in a soft state system, it's possible that the $1,000 will still be in your account while it also shows up in my account. So you'll have inconsistency there, right? We don't really have $2,000 there. We just have it showing up in two different places. However, base transactions are eventually going to reach a state of consistency. So eventually that $1,000 will only show up in one account. But it might take a little bit of time. And most of the time that momentary inconsistency really is for quite a small period. But it can persist for a little bit of time. NoSQL is not a cure-all. It does give availability and performance advantages, but it does so at the expense of those ACID properties. So keep in mind that example of the $1,000. A banker would not be okay with that, right? A banker is going to say that $1,000 has to be in either one account or the other. That transaction, once it occurs, and the money is only in one account. So NoSQL does have some disadvantages if that transactional structure is very important. So keep in mind when you might want to prefer a SQL solution and when you might want to prefer a NoSQL solution. Again, the advantages of NoSQL: it offers availability and performance advantages, in particular for massive data sets. So it addresses problems of scale. With a SQL database, you have to buy a larger server in order to handle a SQL database, and that can get very expensive. A lot of the NoSQL solutions address these problems of scale by allowing multiple machines to be strung together. Hadoop is perhaps the most famous example of that. Most of the NoSQL database solutions offer what we call schemaless data representations. We've looked at entity relationship diagrams and we've looked at how to build in very careful structure for SQL databases. A lot of the NoSQL technologies don't require that level of structure. And because they don't require that level of structure, they allow faster development. You don't have to worry about writing very careful and very complex joins. The most common types of NoSQL storages are document databases, which is MongoDB, for instance, or CouchDB. We're going to take a look at MongoDB in this course. Key value databases. We're not going to look at those directly in this course. Column databases, such as Hadoop, although it should be noted that there are some SQL technologies that allow column storage rather than row storage. So everything is stored in column form rather than row form. And then graph databases, such as Neo4j, which we're going to take a look at in this course as well.